All right. Hi, I'm John Gartner. I'm a fifth-year graduate student in earth science, and I'm studying fluvial geomorphology. I'm looking at how rivers shape landscapes. And one of our projects is to look at dam removals where we see a known disturbance at a known place at a known time. And it's a real full-size experiment on what happens to a river when you tweak it. And so we can test some of our theories about how rivers respond to change. So this is one of my field sites. This is just an aerial photo of it, and it's in southern New Hampshire, and you can see that as we zoom in, this is the town of Swansea, and there's a little dam right here. I'm going to zoom in again. So there's a little dam right there. And typically what people do when they want to measure how a river changes is they'll go out and they'll string a tape across one cross section across the river and measure what happened there, and then they'll go, a kilometer or a mile upstream and they'll do it again. But one of the things that we have for this site is we have the topography for every square meter throughout the entire study reach. So the way that we get the topography over every square meter is they fly an airplane over this site and they literally send a laser pulse over the entire study area, and they fly back and forth for a couple hours, and they get this entire swath, and they're shooting laser beams and counting how long it takes for the laser beam to get back, and that's how we get the topography over this huge 22-kilometer space. So I'll show you what that looks like. This is called Lidar data, and so here's an image of the dam. You can see the dam right there. You can see a covered bridge just upstream and every tree that's there. And we can actually strip away the trees and look at just the what's underlying the trees here if we want. So that's a view of this place, the bare earth. And so we got grants to fly LiDAR over this area before the dam was removed, and then we got them again to fly LiDAR over the same space after the dam was removed. So that's what this looks like. The dam is gone, and they put in some riffles here, and so we can compare these changes. And one thing you can just do is some simple math where we add and subtract these two images and see where were the areas of deposition and where were the areas of erosion.